Hey everyone, and welcome to the Retro channel. And under here, as you've probably already guessed, is a Commodore 64 that is in need of repair. A local viewer sent this over along with a couple of power supplies and an AV cable. Basically, they got in touch and said, hey, I'm having issues getting this Commodore 64 working. Can you help me out? And I gave them a few suggestions of what to check out, but in the end they got stuck, so they've sent it over to me. So let's take a look at this thing, but before we do that, I think we should take a look at these power supplies because they are original Commodore ones, and they may be failing and doing more harm than good to our C64. So let me untangle some of this stuff and we'll hook these up to my little power supply tester, see what results we get. So here's my little power supply tester. It's all pretty simple. It's just a DIN plug, couple of resistors, one of them being over the DC side and the other one over the AC side from the power supply, and a little display which works when it wants to. So all we need to do is just plug our power supply into here and obviously plug it into the mains. Hopefully it won't go bang. We're all good, and we're seeing 4.7, 4.8 volts. That's across the 5 volt DC side, and keep in mind that's under load, so these will get pretty toasty quite quick. But yeah, 4.7, 4.8 is probably okay. We're pretty much maxing out this power supply at the moment across these resistors, so not too bad. Let's have a look at the AC readings, which we'll have to use the multimeter for. So set that to AC, and we can just measure that across this resistor here. And we see about 9.4 volts AC. Again, that's under load, so yeah, this power supply seems to be okay. I'm not going to go into testing the ripple on the DC side. As long as it's not sending too much voltage to the Commodore 64, we should be fine for now. Let's check out this other one. So again, we'll just plug that in there, plug this into mains, and didn't explode. Yeah, once again, we're seeing about 4.9 volts. That seems perfectly fine. And across the AC side, once again, yeah, 9.5, getting close, and 9.7, perfectly fine. On the 5 volt DC side, as long as you've got between, say, 4.7 to 5.3, it's probably fine. And on the AC side, as long as it's between, say, 9 to 10.5, that's probably okay. And keep in mind that is under pretty much full load. So these resistors are dropping around 1 amp across each of them. As for our AV cable, not much to say here. It is only a 5-pin one, so there's no S-video on this one. And I'm guessing these two audio jacks are going to be wired together. Indeed they are. Yeah, I don't really see any issues here, but we'll find out once we hook it up to the Commodore 64. And speaking of which, let's bring it back over, and the reason I haven't removed this leather cover is because I think it has actually adhered itself to the C64 over time. You can see there's some damage up this end as well, which I guess is where the seam of the other side of the cover would have rested. So I'm not going to worry about that. It's not my machine. I'll leave that up to the owner. Main thing we want to do is get this machine back up and running. And it looks like it has the screws reinstalled. So let's get those out. And from the underside, I can see that it's a fairly early model. This one says made in England, but I'm pretty sure that denotes the West German factory, or one of the West German factories around at the time. And it looks like it still has the foil RF shield on the bottom. Okay, let's see what's going on inside. We've got the RF shield. Let's just disconnect this stuff so we're not fighting with this flappy mess. And take a peek. Oh yes, all the chips are removed. I do have them here in this little container. I think when I was talking to the owner of this thing, they did send a picture of the board, and I noticed that all the major chips were in sockets. And they also had a dead test cart, which they've also included. So I suggested just, removing all those major chips and running the dead test cart, because you don't need any of those major chips to boot into the dead test. And I think they tried that and didn't get any further. I think they still had a black screen. So they pretty much called it quits there, which is fair enough. And we do have the 2 CAs, the SID, and the 3 ROMs here. So we'll leave these out of the board for now. There's not much point in putting them in just yet. Let's see if we can get anything more than a black screen off this first. And that fuse does not look too happy. Huh? It's still intact. Okay. So I think what I want to do with this one is see how far we can get with just the dead test cartridge and a multimeter. Dare I say we're going to need an oscilloscope to actually pinpoint the issue, but let's just see how we go with some basic tools first. And before we get to all that, I'm just going to remove this board and we'll take a closer look at it. So at first glance, everything looks okay. The board's a little bit dirty. Obviously, these connectors are pretty dirty, but we'll clean them up later. And yeah, I don't see any MOS branded logic here or any MT RAM, so that's a good start. Let's have a look at the VIC-2 under here. Ooh, a ceramic VIC-2. That's an oldie. 6569R1, which is the first PAL revision. And looking at these little capacitors in here, there are some signs of leakage. So yeah, I've seen that before on these older 407 boards and also the KU boards, especially when there's a ceramic VIC in here, which tend to run hotter, I guess. So we'll definitely need to change those caps, but let's continue examining everything. Sockets look a little bit bleh. They could use some deoxit or something similar. No obvious signs of rework though. All these sockets look original Commodore. Let's pop this PLA out, which is also an old one, an 82 S100, so not one of the Commodore clones. So chances are this probably works. And yeah, that socket under there looks fine. In fact, let's just pop all these out and we'll deoxit or contact cleaner lubricant that socket. Because deoxit is pretty hard to find in Australia. Just gonna put some in my little dispenser bottle here. Right, we'll just leave that to soak in. Let's take a look at the underside of the board because I don't see any other issues apart from those two caps on this side. And on the underside, everything looks fine. I don't see any evidence of rework. There is some flux residue in various places, but I think these are all hand soldered at the factory. So no signs of any work ever being done on this board. So while we've got all the chips out, let's just give this thing some power. We may as well use the white power brick and we'll just check some voltages. I guess we'll start with AC, which should be on these two. Yeah, 10 volts AC, which is perfectly normal. Let's have a look at the output on the DC side. This is the 5 volt DC coming from our power supply. And yeah, it's a little high, but keep in mind, most of the major chips are missing, so that's to be expected. And from our voltage regulators, 12 volts off the 12 volt one, 5 volts off the 5 volt one. Perfect. Let's throw in our VIC-2. We're obviously going to need to replace those caps, but let's just see what we get just with the basics installed and the dead test inserted. May as well use this, seeing as we've got it here. And we'll try it with this AV cable, see what we get. All right, powering on. So we had a black screen. There was a little bit of interference in there though, which is a bit odd. Black screen does tell us that at least the VIC-2 is running and outputting a video signal, but not a lot else happening on this board right now. So I do have to wonder if that's down to these two caps. I mean, they do play a role in the clock generation circuitry. Obviously, the clock is stable enough to give us a video output, but perhaps it's just too far off to actually allow the machine to boot. So I think first things first, let's get these two caps out. All right, caps are out, and yeah, there's hints of green around the legs of those, so they've definitely been leaking, and it looks like we may have some trace damage on the board here. Get some IPA on that first. And I'll throw some fresh solder on, see if we can get those pads cleaned up. Yeah, it's really resisting the solder. Alright, after a couple of passes with fresh solder and then desoldering braid, the underside is looking good. I don't see any issues here. The top side, this one looks pretty good. This one you can see some of the pads being eaten away, but we can still make a decent connection there. I'm worried about this trace running under here though, so I think I'm just going to expose that and just tin it with some fresh solder just to stop any further corrosion. Alright, so I've just exposed any suspect looking traces. We'll throw a bit of flux on this and then just go over it with some solder. Cool, that should be fine. I don't think we're going to need any bodge wires for this one. It was all sort of surface damage, so just sort of thickened up those traces a little bit, hopefully got them back to their original size, and hopefully stopped them from corroding again. Just check continuity. And that one is going under the chip. It's going over there, yep. Yep, that all checks out. That looks good. Let's get some new caps in. What do we need? 10 microfarad, 25 volt. All right, well, it looks like all the 10 microfarad caps I've got on hand are in the 85-degree rated. So I'm going to go with 10 microfarad 50 volt caps. Hopefully they should at least last a bit longer. Okay, new caps are in. Let's see if that made any difference whatsoever. Well, we still have a black screen, so that's good. And that is all we're getting. All right, we'll have a quick look with the Rigol. Yeah, it's not great. I mean, it is actually stable, and it is the right frequency. Yeah, the input looks very jittery. I don't think it should look that bad. Something's definitely not right there. Let's just pop the VIC-2 out, see if that makes any difference. I think we should still be able to pick up the clock input on pin 21. Yeah. Oh, okay. Now it's a little bit better. That's certainly not happy though. I don't think it should look that bad. So I am kind of suspecting U31 here, which I think is a 74 LS629 from memory. The text on it has basically all but rubbed off. So yeah, I think that's our main suspect at the moment. I don't think the crystal is going to be bad, but I guess that's also a possibility. In fact, the crystal is easier to swap, so let's target that first. So much for just trying to get through this with a multimeter. Right, here's a new crystal, 17.73 megahertz, obviously a lot smaller than the original, but functions just the same. I've left a good amount of length on those leads, just in case it does turn out to be the crystal. We can always just fold that over and hook up a new ground wire. There's not much point in plugging in anything else right now. Let's just see how our clock frequency is looking. Yeah, still looks pretty troubled. I don't like that. And grounding that crystal case doesn't make any difference. Yeah, I'm not liking the look of that. 629's coming out. In fact, before we go removing chips, let's just check another board first. So this one here should be the same revision. Oh, it's got a Kawari in it. Let's remove that for now. Well, it certainly looks better. Still doesn't look perfect, but it's better, I think. Put our ceramic VIC-2 from the other machine in here. Let's see what our 1 megahertz signal looks like. Okay. Looks like that. I suppose we may as well answer the question, does this VIC-2 even work? Yes, at least we can safely say the VIC-2 works. That key press is just because I've got the keyboard like this. At least we've got a good VIC-2, that's a start. Seeing as these two are in sockets, we may as well stick them in another machine, make sure they're actually working, and then I guess we'll get into hardcore scoping. So here's my Ziff machine. We'll just make sure that it's still operational. You never know when these things will just randomly die. Okay, it still works. That's always a good sign. Let's swap over the PLA, which is in a different position on these boards. So it's in a higher position on the 407 boards and the lower position on the 425 boards. Oh. Could it be? That's a bad PLA. Well, I'll be damned. And yeah, that's one of the Signetics ones, I think, because it's got the S on it. It doesn't say Signetics, but I definitely don't think it's one of the Commodore copies of it. 8232, so it's quite old as well. Wonder if the CPU is going to work. CPU does indeed work. So, a bad PLA. That's going to be pretty boring if it turns out that's the only issue. Well, I guess those caps were leaking, so at least we had one other issue, but is it just going to be the old PLA? Obviously, we'll still need a dead test cart for this one. Oh, it was already powered on. Start that again. Oh, yep, we've got an image. Not a very happy image. That's certainly down to that crystal, or our wonky clock frequency. Let's see if we can adjust that a little bit. Yeah, that could just be this dirty trim pot here. Well, it looks pretty happy if I turn it that way, but now we've got U21 bad. Is that just from me messing around with this clock frequency, or do we really have a bad U21? And now the colors are all messed up again. I'm not going to touch it. Let's just see if it gets through the dead test. U21 bad, color RAM bad. It certainly doesn't look like a color RAM fault though, because we can get stable colors if we just tweak this a little bit. Well, almost. Still suspecting this 629 here. So I don't think there's any reason at looking at anything over here just yet. I really do think this is more of a timing issue due to these wonky clock signals. So let's get this sucker out. Right, I took a little break and used that opportunity to clean up the bench a little bit, and I also pulled down that Commodore 64 that was up there and had a look at the clock signals on that again, and yeah, these boards both look pretty similar, but I soon realized the answer for the clock problem might be staring me right in the face. The Kawari itself has an onboard oscillator, so it actually generates PAL and NTSC crystal frequencies and doesn't rely on any of this clock generation circuitry. So let's stick this in the board, see if we have the same issues. Oh, and I also replaced that fuse. Even though it's intact, it just looks a bit ugly. So we do have the option to use the oscillator on the Quarry. Oh, and yes, we do have solid colors now, which is a good start. It does mean that there is definitely an issue in this clock generation circuitry though. Let's see if we can pass the dead test now. Oh, no. We still get color RAM bad and U21 bad. That's a surprise. We can also swap the Quarry to use the onboard clock circuit, so let's see what happens there. Dare I say we'll have the messed up colors again. Yeah, messed up colors. So definitely an issue with this clock generation circuitry, but it looks like we do indeed have an issue over this side of the board as well. So I think I'm still going to start over here with the 629, which is sort of the main part of the clock generation circuitry on these boards. There's also this supporting logic here, and to be honest, I don't fully understand how it all works, but I know the 629, I've had one of those go bad before, and it also had these leaking caps on the board. So let's start with this guy. Yeah, it's pretty gross underneath. All right, let's get a socket in there. Alright, with our socket installed, let's throw in the original VIC-2, and I might grab the 629 out of my other bread bin because I'm pretty sure I saw it in a socket. Yes, it is. In fact, this might be the board that had the leaking caps because it looks like I've replaced them, and it's probably the one that I had to replace the 629 on. So here we go again. Stick that in here and see what we get. RetroTink's doing its RetroTink thing, but we have solid colors. Play around with this trim pot a little. Yeah, it seems happy now. I'll just set that to the mid position. Should be fine for now. And of course we still have color RAM and U21 bad, but at least we sorted out the clock issue. In fact, let's throw this in my good board, see if it does the same thing. So we'll throw in our dodgy chip, and I'll put the Quarry in, but I'll set it to use the C64 oscillator. Oh, here we go. Ah, yep. The picture is all screwed up. So yeah, definitely a flaky 629. So far we have bad PLA, bad 629, a couple of bad caps, and something else that's bad. And I'm pretty sure I've seen a similar issue before. In fact, pretty sure I included it in another video on a Commodore 64 repair where we had a bad RAM chip and a bad color RAM. And after checking out my last video, it turned out the kernel ROM was bad on that machine, and obviously we don't even have a kernel ROM here. But it was data bit 0 on the kernel ROM, which was stuck high or stuck low or something. That was messing up the data bus, and that was causing the dead test to fail. So perhaps there's something on this board which also happens to be data bit 0, U21, that's causing a similar fault. Could be the RAM chip itself, but then again it could be anything else connected to D0. Alright, so back with the scope, let's have a look at what data bit 0 is doing. We may as well look at it directly from U21, so I think it's pin 2 on these. Yeah, that looks fairly normal. Looks about the same as the other data bits. So maybe not an issue. I don't see any issues on the RAM itself, certainly not on data bit 0. Where's the color RAM? Let's have a peek at that. Color RAM also looks pretty normal. I don't see any major issues there either. Just going to keep poking around with the scope, and I'll stop if I find something odd. Well, I found one oddity. This is pin 5 on the PLA, which is labeled as VA14. I'll have to look at the schematics to see what that is, but yeah, it's stuck around 2.5 volts. So VA14 is going to U2, which is one of the CIAs, which obviously isn't even installed, and this 74 LS258 at U14. So I'm kind of suspecting this right now. It's kind of hard to make out, but it looks like pins 2 and 3 are an input on this, and they go to an inverted output on pin 4, I think that says. So with pin 2 like that, and pin 3 having activity, the output on pin 4 looks somewhat normal. I mean, I'd need to compare all 3 at the same time, but yeah, that input just doesn't look right. Nothing should be just floating around 2.5 volts. And without the CIA, there's nothing else connected on that line, only the PLA and U14. I suppose we can bend that pin out on the PLA just to see if it makes any difference, but this was working in the other machine, so it should be working in this one as well. So I've just bent pin 5 of the PLA out of the socket. Let's see what it looks like back over here. Yep, still sitting around 2.5 volts, but now it just looks like a bunch of noise. And on the PLA, that pin is just low. So yeah, definitely looks like an issue with U14. Now, how all that relates to the color RAM and U21 being bad, I'm not so sure. Anyway, let's get U14 out and see what happens. Suspect chip is out, socket is in, and here's a known working 258, so let's throw this guy in, see what happens. Oh, it's still bad. God damn. You won't be able to see it, but looking at it on the scope, it looks exactly the same. On my other 64, that line is held high, so what's up with that? Is there something wrong with this PLA? Yeah, it's high, even with that PLA in the board. What is that? What? Huh? Is it because the CIA is not in there? Yeah. Okay, yes, that line is now high. So the reason it's just sitting around 2.5 volts is because there was no PLA in there. So I guess that's totally normal if you've got the PLA removed. And yeah, definitely wasn't the issue here. Well, another socketed chip, so be it. And the ZIF board confirms that there's nothing wrong with that 258. So back to square one. Well, after poking around the board, the only other thing that I can see that maybe looks a little bit odd is address line 8, which does happen to be on the color RAM. It's also on this multiplexer over here, which I guess is handling U21. Maybe that's something? If we get a single shot. Yeah, there's some random little dips like that, but that might be normal. It really is hard to tell, so I think I need to take a little break from this board, have a little think about it, and resume tomorrow because it's now beer o'clock. Alright, it is the next day, and I spent all of about 5 minutes last night thinking about this, and I think I should just bite the bullet and replace the color RAM. Obviously, the kernel ROM was the fault with the last board, even though the dead test was telling me it was the color RAM, but I think in this case, it probably is the color RAM, and I should just take its word for it. So let's get this thing out and get it replaced. Alright, socket is in, and I've got the color RAM from the ZIF board, which does have a little heatsink on top of it. Some of these do tend to run quite warm, so I guess it wouldn't be a surprise if the old one had failed. Well, there's one way to find out. It's going. Well, dead test was right. It was the color RAM this time. What are you doing? What? Oh. All right. Are we done here? big fluff ball that is Hank. Are you good? He just wants to go in the window, sit in the sun. There you go. Anyway, looks like dead test passed. Obviously we don't have any sound or the timers because none of that is installed. So let's try out this box of chips. Let's go all out and just install all of these, see if it still works. I'll be incredibly surprised if it actually manages to boot into BASIC, but let's see. We have a black screen. Alright, let's pull out the SID. Yeah, I didn't think that was going to fix it. Let's pull out the CIAs. We might get lucky, well, maybe unlucky because CIAs are pretty expensive. Going to be one of the ROMs. We can pull out the basic ROM. It'll still boot. We'll just get a blue square on a blue square. It's not the basic ROM. We can also pull out the character ROM. Obviously characters won't work, but we'll still get blue on blue. Aha! Right, let's throw basic back in. RetroTink is being ridiculous, but we do have a working basic ROM. The characters are all screwed up, of course, because there's no character ROM to read from. May as well throw these other bits back in. And throw the SID back in. And with everything else installed, it still boots, so hopefully just a bad character ROM. Here's a nice fresh one made by yours truly. Perfect. No, not perfect. There is no cursor. Looks like one of those CIAs is dead. I'm pretty sure it's the second one that handles the cursor flashing. Let's just swap these around. In fact, let's just put the first one in the second socket. Oh, still no cursor flashing. Maybe it's the first one that handles that. I don't remember. One of these is bad, I'm sure of it. There we go. We've got the cursor flashing. No doubt we're going to have an issue with like the serial port or something because that's mostly handled by the second CIA. So let's throw on the diagnostic harness and see what works and what doesn't. Before I do that, just give these a bit of a clean. Alright, all our ports and edge connectors have gotten clean, diagnostic harness is on, and diagnostic cartridge is in. Let's see what happens. And yeah, straight away, once the RetroTink sorts itself out, I can see that the second timer is completely wrong, so that CIA is definitely bad. No doubt it's going to fail some port tests. Yep, a whole bunch of them. Let's throw in a known working CIA. Ports are good, timers are good, SID is possibly good. It does have one of the older kernel revisions though, which does show some bugs in certain programs. Give you a quick example of that. So with our keyboard connected and the SD to IEC hooked up, I'll give you an example of what this kernel bug looks like. Caps lock is on. At least the keyboard seems to work. So you can see as I scroll through the file browser on FB64, all the colors get screwed up. We get random blue and white everywhere. And that is one of the bugs with this revision 2 kernel. So let's swap that out for a Rev 3. It's not a huge deal, but it's just a minor annoyance, and it can affect other programs as well, not just FB64. Here we go, here's the Rev 3 kernel. And as you can see, no issues there. That folder there must be in uppercase, so there it is. But yeah, no worries with the Rev 3 kernel, and the Rev 2 kernel doesn't really matter that much, but I'll get in touch with the owner, see if they want to upgrade it. Definitely they're going to need a new character ROM, so we'll see how that goes. So I guess the last thing to do here is properly test out the keyboard and the SID. Keyboard is fully working, so although this cover may have messed up the case, it probably protected the keyboard pretty well. You can see those random dots in the green background there. That's probably also caused by the second revision kernel. Go. Cool. No issues with the SID that I can detect, so this is looking good. One last thing I should probably check is the S-Video output, or the Luma Chroma output. I won't worry about audio, let's just make sure this works. It certainly does. It looks slightly better than composite, but still not great. That's more down to this old RF modulator from the early revision C64s. The Easy Flash 3 menu is a good test for this. Yeah, that doesn't look great. I mean, the colors are weird, but that's because of the ceramic VIC-2. They're different from the later models, but it does look pretty blurry even with S-Video. As a quick comparison, here's the same board revision with that same VIC-2 from the other machine and my RF replacement. This one doesn't have the output jacks because I actually just use this machine to test the RF replacements before sending them out, but we should be able to tell a pretty significant difference. And yeah, there we have it. So much clearer text. Obviously the colors are still weird, but that's because of the ceramic VIC-2. And maybe you can spot a little bit more noise in there, but again, that's more the ceramic VIC-2 and this older revision board. Sharpening up everything also sharpens up that noise. So not much we can really do about that, but certainly an improvement over the original RF modulator. So there we have it, very much a mixed bag for this one. We obviously had a couple of original power supplies that are still currently working, although I don't know if they should be trusted in the long term. We of course had a total of 5 bad ICs, a couple of leaking caps, an ugly looking fuse that is still intact. Oh, I should put this crystal back in because there's nothing wrong with that. But as for the rest of this machine, I'll leave it up to the owner to do the cleaning, and I'll see if they want replacement ROMs or a replacement RF modulator. But yeah, an interesting one. I kind of enjoyed this one. It's always fun to see these fail in so many different ways, and they always tend to keep you on your toes. So hopefully you picked up something from this video if you're troubleshooting Commodore 64s yourself. And yeah, always good to have a second machine handy that's actually working so you can swap parts in and out and test them. That is it for me. Hope you enjoyed it. Leave any comments or thoughts in the comments section down below. And a big thanks to the people that support the channel on Patreon and help me to continue making videos like this. Yeah, that's it. Bye. Are you going to say goodbye? Guess not. Ooh, bird.